In this tutorial video, we will be comparing some of the strategies that can be used when designing the drop section of the network. Let's get started by loading in the design view of our area. First, let's go through the rules that we have defined for this specific workspace. Open the rules for the drop layer. The first strategy that we will explain is the drop strategy for buried-only designs. This strategy is typically used when designing a network without any aerial connections. Now we wait for the calculations of the drop layer to finish. We can immediately inspect the output. The results of each calculation are grouped per layer, so in this case, we should check the drop layer. You'll notice an entry for the drop points, the drop cables, and the drop ducts. In this workspace, during the input processing, we have created shared drop trenches. Let's inspect the drop point associated with these buildings. We can see it has a home count of 2, which indicates that 2 buildings are connected to it. The fiber in attribute indicates that it is providing 2 fibers to the demand points below it. Similarly, the fiber out attribute indicates that it requires 2 fibers from the distribution layer as well. If a splitter was placed in this drop point, these 2 attributes would have different values. Let's also take a look at this isolated point over here. This one has a home count of only 1 building and corresponding fiber counts. We can also take a closer look at the drop cables. In this case, a drop cable is used, which is an underground cable. It has a granularity of 2 fibers. In this scenario, we don't have any aerial poles, so all of the cables will automatically be underground cables. Let's now examine a more complex drop strategy, which includes aerial deployment. Before we continue, I will load in a workspace that already contains some aerial facilities. As you can see, this workspace contains the same area. Compared to the previous workspace, however, it includes some pole locations. These will provide the possibility for aerial interconnections. Again, let's check the rules before we start the calculation. In this case, we selected the drop strategy for aerial networks, instead of the strategy for buried networks, which we discussed previously. Let's recalculate the drop layer for the aerial design and inspect the results. At this point, our view is very similar to the one we had before. Notice that this workspace is using single drops as opposed to the previous situation. Let's take a look at the area which has the aerial poles. The cable types of these cables now indicate that they are aerial. They are all connecting onto one of these nearby pole locations. When doing an aerial design, it's useful to switch to the customized aerial design view. In this view, you'll notice an additional layer in the drop part. This layer is called the drop clusters layer. It adds some polygons to your design that indicate which demand points are grouped onto the same drop point. This helps with showing which demand points make up the aerial drop clusters. We can inspect the attributes of this drop point as well by selecting it with the identification tool. You'll see that it has a home count of 7, corresponding to the amount of buildings it is serving. We can also use these polygons to force multiple buried demand points onto a single drop. To do so, first select the drop clusters layer and make sure that it is being edited. Using the Node tool, we can draw a new polygon over some of these demand points. There is no need to fill in any of these attributes. Just press OK. This has automatically locked the newly created polygon. Now, let's rerun the calculations on the drop section. The two buildings in our polygon have now been connected to a single drop point. We can inspect the drop point again, which will show us that it has a home count of 2 homes. Even though we have now forced a shared drop point for 2 buildings, note that the cables are still reusing the single drop trenches that we created during the input processing phase. On top of that, a small section of street-side trenching is used for the second drop cable. This concludes the explanation of the drop calculations. The next step would be to create the design of the distribution layer.